Kubernetes operators. I've been asked for a long time already to create a lecture about Kubernetes operators. So finally, I'm going to show you how you can write an operator, a Kubernetes operator in Golang. So how to write a Kubernetes operator? There's actually multiple ways to get started. You can use the operator SDK, or you can use something like Kubebuilder. Both libraries or binaries, packages, they will for you create the code necessary to start working on operator. They use the controller-runtime, which is a GitHub project from Kubernetes, to interact with the Kubernetes cluster. But of course, if you use the operator SDK or Kubebuilder, you don't really know what is going on. So I wrote a custom controller. So here there's a third box here, the custom controller code. So that's what I'm going to show you today, that uses also the controller runtime. So I'm skipping over this software that can make it easier to build an operator, and feel free to use the software. It will just generate the code for you automatically using the controller runtime. But it is a good idea to first understand how the controller runtime works and how to implement it in a Golang program. And then maybe later you could use operator SDK, the Kubebuilder, or even write your own custom controller code using the controller runtime to make it easy. So when we talk about a Kubernetes operator, we're going to use custom resource definitions, CRDs. That's basically just custom YAML resources within Kubernetes. You define what attributes you want to store. And in this demo, I'm going to create a static page CRD. So that's a custom resource. And when we're going to create a new resource of type static page, we're just going to start an Nginx deployment that starts a pod, and we'll inject a custom page. So that when you go to this container, it will just show you a message. And that message is basically just what we use as our index.html of our Nginx container. To achieve this, we first need a custom resource definition, but then we also need a controller. So the controller is where you write your own custom Golang code. You're going to use a deployment to deploy that controller on a Kubernetes cluster. Mine is going to be called static page controller, static page in lowercase though. And then the static page controller is going to use a controller runtime. So the static page controller is just also a pod, a controller pod with some custom Golang code in that is going to use the Kubernetes API to interact with it to see, is there a new static page? If yes, create a new container, a new Nginx container. If the static page resource is updated, then update this container. If the static page is removed from the Kubernetes API server, then remove this resource, this deployment, this pod from the Kubernetes cluster. So it should be fairly straightforward. So I will show you what code is necessary for that. I tested a few approaches, and I think using this controller runtime is actually the best approach compared to writing your own Go Kubernetes clients, because that's also an option. You can have your own client package that can interact with those Kubernetes resources. But controller runtime is an abstraction above that. So controller runtime is going to do that for you. They are basically going to give you the boilerplate code in that package to interact with the Kubernetes API server so that you don't have to do that. You will just have to supply the config to connect to the Kubernetes cluster, and then they just basically give you a function. If static page, in our case, changes, do something. I had some troubles using this client. I use this if you want to write your own custom client. It's not that easy. It's not very well documented. So that's why I abandoned it and went for controller runtime. In the past, I used a custom client and it worked. So it's a little bit more research. You also need to have like the correct Kubernetes version, the correct Go client for Kubernetes. It all needs to work nicely together, whereas the controller runtime can give you some abstraction so that you don't have to worry about these details. Still, if you just want to connect to the Kubernetes cluster, it's just a REST API, so you could just use a Go HTTP client library even to have a look what is on there, do some REST API calls, get some JSON back. I think it's JSON. Just YAML is human readable, but I think when you would write your own client, you actually just get a JSON back, which you can then put in a Go struct, and then from that struct you would actually kind of make changes to the struct, read from the API server, write to the API server, and so on. So it will become more clear when I go over the code. So what is necessary to use a controller runtime within Go? So this is my Kubernetes Operator project. I have this on GitHub as well, so I'll make sure that there is a link to the GitHub repository in the description of the video. So here I have 3 directories. I have my YAML definition, my crd.yaml, which is of kind custom resource definition. So this is where I'm going to find how my new resource is going to look like. It's not very readable. So let me just open an example here first. So this is the object that I want to create. I want to have an API version that's unique, kubernetes.infra.com, I called it, /v1. Kind is static page. I have metadata, which is the same as a normal Kubernetes object or Kubernetes resource. And I have my specification, and this is actually my custom attributes that I want here. So I want an image. Nginx latest is the image I want to use. I want to put this contents in it. This is a test. I want to have 1 replica. So to be able to apply this to my Kubernetes cluster, I need this crd.yaml. So this will actually be the first YAML file that you can apply to your Kubernetes cluster. So this is of custom resource definition. I give it a name, a group, the version, and in this version I have my specification that I have contents, image, and replicas. It's namespaced, plural, singular, kind, short name. Pretty straightforward. But now I need to build a controller. So this I can apply easily to my Kubernetes cluster, then apply this, but this is not going to do anything because now I need to have a controller that it will listen for any change of this static page. So how do I do that? I have the CMD controller and a main.go, but maybe first let's have a look at the API that we need to have, the kind of boilerplate code that you can easily have generated, but I just created it myself. So as I was saying earlier, we get JSON back from the Kubernetes API server, so we have to translate that JSON into a Golang struct. So we have a type static page struct where we have the specification in JSON that what will be returned from the API server. The Kubernetes API server will be spec, and then contents, image, replicas. So this is my static page spec that will be translated from Kubernetes API server from JSON into this struct, and then I'll be able to use this struct in my Go code. So these I just generated myself. There, you can just kind of get these contents from this file and then use it for all the other Kubernetes objects. This is how every Kubernetes object works. It uses the meta v1 list meta and type meta from this package for the metadata, because this metadata is always the same. Then we have a deep copy, which you also need. So let's say that you want to copy these objects. You need to have a deep copy function. There's an interface that we are going to use that needs this deep copy. So if you then make a copy of this struct, then it will also copy everything what is in the specification. So this is just some boilerplate code that I copied from somewhere, from a project that said you need this deep copy. This is how you do it. So I also actually ran the Kubebuilder to see what code it generated. So then you can also use the Kubebuilder and see what code it generates to also have this deep copy in there. This code is not automatically generated, but Kubebuilder could generate it for you. And then we need the register. So basically in register, we just have the group name, the group version in here. We will then use these functions to make sure that when we use a Kubernetes client in our controller, that we make this Kubernetes client, which is then kind of embedded in this controller package, that it is aware of our new schema. So that's why we need this register.go. So this register.go is not going to do anything. We just need this at known types and these constants here in our main.go. So let's now have a look at kind of the meat of our Kubernetes operator, which is the controller. So what is the controller going to do when we deploy it? What does it need to do? It needs to run forever. And whenever there's a change in our kind static page, whenever a new resource is created, changed, deleted, we need to get notified. So we need to have a function, and that function needs to be executed whenever there's a change. And this controller package from Kubernetes is going to help us with that. So let's go over the code that is necessary to create the controller, the most basic controller. And we are going to use this controller-runtime that I was talking about earlier. Here we have the Kubernetes Operator Demo API v1. This is this directory here. So whenever infrit v1 is prefixed, it actually is this folder. So within our main, we are already going to use a scheme. And here we have an init function. So we're going to declare the scheme here. Scheme equals runtime new scheme. Runtime comes from the API machinery. So we're just going to say, okay, we need a new scheme. Scheme is what contains all the resource types in Kubernetes. And then here, that was what I was talking about. We are going to execute this add to scheme function with this scheme as an attribute, as a parameter. Let's have another look at the register. So add known types, add to scheme. Add to scheme is scheme builder. Add to scheme, and scheme builder is a new scheme builder. So we're going to create a new scheme using the builder, add known types as this function as a parameter. And then so this add to scheme is actually what call here. So this is, we are going to create a new scheme, and then we're going to say, okay, using this new scheme, we need to have these group name version, our scheme that has the static page added to it, so that it's aware of it. We are going to use the setup, we're going to use the log. So this is just something that comes from the controller runtime. We need to make use of a logger. I just copy pasted basically from the Kubebuilder that uses this log zap, the log system. So then we are going to create a struct called a reconciler. And this reconciler is going to have a function, the reconcile function. So this is the function I was talking about. Every time there's going to be a change to our static page, this function is going to be called. So this is really the business logic of our controller. If anything changes, we are going in here in this function. So I'm going to skip this function for now. I'm going to explain how we built first all the rest, and then I will have a look in this reconcile function. So this we skip for now. Let's have a look at the main function. So this is first we had set scheme and setup log. We do the init function. Init is executed first. So now we have a scheme, we have a reconciler, but how do we actually start the controller? That's going to be done by the main function. So the main function, this code here is something I added myself. So we can start this controller in two ways. Locally on our machine with a kube config, or within a cluster using the in-cluster config. So I'm just going to check homedir.kube/config. Does this exist? The kube config. If it exists, then we're going to execute this code, build our config from this kube config. That means that we are running on a local machine. We have something like Minikube that I'm going to use later. And basically we do go run of this controller. We have the kube config available. We can connect to the API server using this kube config. Generally, within a pod, when you deploy a controller within a Kubernetes cluster, you don't have the kube config available. There is a token mounted somewhere that you can use. So if this kube config is not available, then use the Rust in cluster config. Rust is the client Go. So we can create a Rust client to be able to connect to the Kubernetes API server. So we basically do either in cluster or out of the cluster, depending on whether this config is available. And then we ask for a new client set using this new for config. We set the logger using zap new, and then we actually now starting with this controller runtime. So this was all kind of generic. We have a Kubernetes client. Now let's invoke the code that is necessary to run our controller. So we say we need a new manager. And here we pass the scheme that we created that knows about our own custom resource definitions. We're going to pass. So now we have this manager. This is a new manager. New manager returns a new manager for creating controllers. If we have an error, enable the start manager. Then we say controller, or like the controller runtime, new controller managed by. Returns a new controller builder that will be started by the provided manager. So we pass the manager here. Say for defines the type of object being reconciled. So we want to reconcile, we want to make made aware of any update to this static page. So this comes from our v1 package. Static page, whenever there is a change to this static page, I will be aware of it in my controller, in my reconciler, being reconciled, objects being reconciled. So I need to make this manager aware of, or this new controller aware of my reconciler. So I say complete. Complete builds the application controller and takes the reconciler as an argument, as a parameter. So I say this is my reconciler. I have a client, manager get client. This gets the controller client. So it has a separate client here. And then the scheme, my special scheme. So this client is going to be our client for our static page. Then we also have the kube client, which is our client set that we created earlier to access all other objects within our Kubernetes cluster. So if you have a look here, the new manager, we say, okay, we have this scheme, we have this is our config, is going to create this client for us, and we can get this client using the manager get client, and we can get the scheme using the manager get scheme. This client set comes from here. This is the client that we created. It's just a generic Kubernetes Go client set. And then in our reconciler, we actually say that we have this client interface, but we then also have the scheme and the kube client. So this kube client kind of added it extra so that we, in our reconciler function, we can also use the generic kube client because we needed to, for example, make a config map, make a deployment. So back to our code at the bottom here. So this is just going to create and start our controller. If we have an error, we exit, and then we can start our controller. And this starts all registered controllers and blocks until the context is cancelled. So this is then going to run forever. So this is going to run forever, and then we're going to use this reconciler function. This reconcile function will then be invoked every time there's a change to our static page. So what are we going to do when there's a change? Well, like I said, we want to create this Nginx deployment, mount a file in there that says this is a test, our index.html, and then the amount of replicas. So then we can say, we just can say that we log something, reconciling static page, so that we see on in our output, in our logs, whenever we change an object, that we actually see something. Create deployment if it doesn't exist. Deployments client and config map client. So this comes from this kube client. This is generic client that we can use to communicate with the API server that is aware of the deployments and the config maps. Ideally, and actually I didn't really figure out how to do it. Ideally, you would have here this client of the reconciler. And this client is a client to communicate with the API server, but it's not a full client. This client may not be a fully direct client. It may read from a cache, for instance, see options and so on. But this client also only knows about my static page. And maybe, and I'm not really aware how this would work, maybe you can also make it aware of the other Kubernetes standard objects that are in there, so that you can also use it for other REST actions to deployment to config maps. So what I did here is I use this client I use only for static pages, my own custom resource definition. And then I have a separate client that I use to access deployments and config maps. So maybe you could put it in one client. I haven't figured that out. Maybe if I figure it out, I could make another iteration of this code. But for now, it's a separate client. So that's what I do here. Our kube client, give me the deployments and give me the config maps. So this is just an interface, deployment interface, that I can then use this client for deployments and this client for config maps. So my static page name is going to be static page as a prefix, and then the name of this resource or rec name is actually the request, which is going to be this one, name from the metadata. So I'm going to get, using my client for the custom resource definition, I'm going to get the static page information. So I have in this static page variable my static page. So this static page will then have, can I see it here? Static page will then have this specification in it that I need, that I can then use. So I get my static page, and if there is an error in getting it, I'm then going to check if it is a not found error, because if it's a not found error, static page is not found, and we can delete this resource. So this is actually the code that we going to hit all the way at the end if we then delete the resource. So here, I just want to make sure there's no error. If there is an error, that I catch it. And if there's an error in getting this static page, it means it's deleted. So this reconcile will also be invoked when you delete an existing static page. And when you delete an existing static page, this will be invoked, but the static page doesn't exist. So that's why we do is not found. If we get an error and it is not found, then we can delete our whatever we created. So let's keep this for now. So let's say that our get worked successfully. So this code is skipped. What are we going to do? We are going to do a deployment. So we're going to say deployments client. Let's see if it already exists. Do a get on the deployment using the static page name. If we get an error, that means it doesn't exist. So we can say here, the deployment that we're looking for is not found. This Nginx deployment that we want to do. Let's create a config map and let's create a deployment object to create our Nginx container, and the contents, this static page spec contents, goes into a config map, and that config map is then created. So this uses two functions here: get config map object, get deployment object. If we have a look at these are defined at the bottom. Then we have here core v1 config map, and here apps v1 deployment. So this is just our YAML code, but then in using structs in Go to create a deployment, app static page, and then create a config map with the index.html contents. And then we have here the volume mount, where we have the contents that we mount this config map in our user share Nginx HTML. So these are just definitions. So let's go back where we left. So we checked deployment. Does the deployment exist? We got an error. It says it's not found the deployment. So let's create this config map. Let's create this deployment. If we get an error and it's not a not found error, then we say deployment get error. Then we'll just see that in the logs. And otherwise, if we can create these two, they will also show in the logs that we create a new static page. If we found the deployment, that means that we're actually doing an update because our Nginx deployment already exists. So we say, okay, if it's found, we need to update it. And right now, the only thing that I'm doing is just changing the replicas and then doing an update. I'm not changing the config map. It's just an example, a demo. So I was like, I'll just see with replicas, if this attribute is updated, I will update my deployment. But you can also check if the contents has been changed, for example. And then I say the static page is up to date at the end. And then return. And if I do an update, I also say something else. Static page with name updated. Just so that I, in the log, can see what is really happening. So back to this delete code. So let's say that you first run it the first time. So that means that it was not found. This code will be executed. You run it another time to update the replicas. It is found the deployment, so this code is executed. But then you remove this example YAML code, you remove this test page, then reconcile will be invoked. You do a get of the static page, and it says it's not found because it was removed. Then you can say, I'm going to clean it up, deployment, delete, config map client, delete, to clean up my cluster. So this is the most basic code to create a controller that can interact on changes made to your own resource definitions. So let's execute all this. Let's build this controller. I have a Docker file here if you want to run this within a cluster, or you can even just run it on your local machine. As long as you have a kube config file, then it should be able to execute. So I have a Docker file here, and I have a README. So you can build it. You can copy the Docker image within your Minikube if you want, and then you can deploy it. So I'm not sure if I want to build it. I should be able to run it on my local machine. I just need to have Minikube running first. So if you are on the macOS, brew install Minikube. If you're on Windows, you go to the Minikube website, you download it. Minikube start. I removed my Minikube cluster earlier so that I'm starting fresh. So what do I need? I first need to apply the CRD. Then I start a controller in cluster, or just on my local machine. On my local machine, I'm admin. Here is deploy controller. It will need roles. So if you go all the way up, so this is deployment for the controller. You see that we are using a service account. Service account is defined here. And then we need to get access to deployments, the config maps, but also on a cluster level, we need to get access to these static pages. So if you want to do an in-cluster deploy, you also need all this. So let's just do a run from my local machine. That's a bit easier. Okay, so I have my CRD. So I do kubectl get static pages. Okay, that exists. If I do something else, it does know about it. So it knows about my static pages right now. So I could deploy an example. So let's first run my controller. So you can either do it like this, go run start.go, because I have my, let me just create another terminal. I have my kube config here. It can actually connect to the Minikube cluster, and I actually have a command somewhere. You can also just do a curl. So if I would have a look here, what a server is, you can actually do a curl on this, and you could use -key -cert to pass the cert and key, because it's MTLS, to have a look how the Kubernetes server looks like. So if I just do it like this, -k, because I don't have the CA, it actually responds in JSON. So that's what you see. And it says system anonymous is forbidden because I'm not authenticated. Let's just have a look, because actually this is easy to, this is actually good to know for debugging. Certificate authority is here, and then the client certificate is here. So cert is this one, key is this one. All right, curl. So now I have access to all these endpoints. One of these should be my static page. APIs, kubernetesinfra.com. So it's not really a static page. It's first, they list the, what is it called? The API version, the group name, API version. So actually I want this right here. So let's have a look. What happens if you hit this endpoint? API group v1 kubernetesinfra.com, group version, preferred version. So we need to go to v1. Let's clear it first. It's more readable. So API resource lists, and it actually says we can do a delete, a get, a list, a patch, a create on this static page. So now I actually don't know for sure how to static page, maybe just with a slash, static pages. Ah, yeah, static pages. So now we get a list. So if you do kubectl get static pages, that's actually behind kubectl what's happening. It's going to make this API call. There's some JSON that's being returned. JSON goes into the Go client, gets translated into a struct. Struct prints it nicely on your screen. So let's create one. So we have here this manager that was started. Starting workers for the static page. So kubectl apply -f YAML example.yaml. And then we see here immediately reconciling static page. New static page with name static page, test page created. So if you go back to this code here, new static page, where we invoke this code. So let's go back. kubectl. kubectl gets static pages. Here's a test page. What does our API say? API version items. Now we actually have, now we see something. So this is directly from the API server. This was basically the resource that you were watching. So this reconcile, this controller is watching these resources, and when there's a change, it sees a change and then it invokes this reconcile. So what then happened? Let's have a look at the deploy. Static page, test page. We have a pod. Static page, test page pod. We should also have a config map. Static page, test page, config map. kubectl exec is pod bin bash. Now we are in this nginx. Okay, we don't have ps. Curl localhost. This is a test. So we actually should see users share nginx HTML or index HTML being mounted in the config map. So that all works. So that is pretty straightforward, I think. But yeah, you don't want to run this worker on your local machine, so there is still some work to get it running on your Minikube or Kubernetes cluster itself, and that's why we had this deployment.yaml. Deploy controller. So what do we need for that? We need to first build it. Docker build -t, give it a name of the current directory, or you can use Minikube. Minikube also has a build function, or you can use the, if you have a look at the README, the Docker build, and then the Minikube image load or the image Docker image save. So these are all options. So I need to do a build. I'm going to do the build right now because I just realized that my image is actually not on my Minikube cluster because I deleted my Minikube cluster. So I should execute these commands because initially I thought I can just do the kubectl apply of this deploy controller. So let's save this image. So I need to do these 3 commands because my Docker version is too new to be able to work with the Minikube image load. There's some incompatibility somewhere. So I'm loading this image now. Okay, this image should be loaded. Minikube images ls, I think, or image ls. Okay, here it is, static page controller. So if I now do kubectl apply -f deploy controller, YAML deploy controller, then you can see it created deployment, the service account, and the role binding, cluster role binding. So the cluster role is for the custom resource, and the role is just so that you can see the deployments and the config maps. kubectl gets deploy. So now we see we have our controller right here. So actually we didn't remove our test page, so this it's still here. We have controller, kubectl get pods. We have our pod. kubectl logs of this controller. Static page is up to date. So that was also somewhere in our code. If we didn't do anything, static page is up to date. So our controller is running. So let me, okay, this is our logs. Let's have a look what happens if you do a kubectl delete of this static page. YAML example.yaml. Now this test page is deleted. So if you do the curl, no items. Reconciling static page. What's it saying here? I don't get a lot of outputs, but I think that is because I'm not outputting anything here. I could maybe have another log line. If I would have another log line, I could say, okay, we deleted our static page. kubectl get deploy. Okay, so we only have our controller anymore. The static page is gone because our controller removed it. Same with pods, same with our config map. So our controller cleaned up everything. And I've shown you now that this controller can actually run locally, but also within the Kubernetes cluster. You just need a Docker file to build the image, container image. This is the controller, then there's the binary. You can have it deployed on your cluster. And then this code right here is making sure that we can run it either locally with a kubeconfig file or on the cluster. And whether we run it locally or on the cluster, it's just gonna look for any changes into our custom resource definition. So I actually find that this custom code there's not a lot of code necessary to run a controller. So this package here, the controller-runtime, is doing all the heavy lifting. So that's actually pretty good news that you don't need a lot of boilerplate code, but it's still quite a lot of work to create then this Golang code for every kind of property that you have here, the contents image replicas. So this code, even though I created manually for the purpose of this demo, Kubebuilder Operator SDK helps you generating this code every time you update your CRD. So let's say that I need a new field. I need a new field. I have something else here, a new field. Well, then I need to regenerate all this code. And just keeping this up to date, it would be easier if you have some generators. So you can use something like kubebuild as a generator. And then when you use kubebuild, you'll actually see that it generates this code, this manager and this controller. Because I did it myself as well. This is a project that is generated by Kubebuilder, and you will actually see some of this code coming back. Manager start, setup with manager. So it does the same, but it gives you some more auto-generating tools, so that you don't have to create this all yourself. So you see all these things going back, but it actually auto-generated that for you. So it depends on what way you want to go. Some people say, okay, I want to have full control of my code, so I don't really like these generators, I will just do it myself. Or you can use something like Kubebuilder, which will generate this code. And the code that I explained to you, you see here you have the reconciler. Setup with manager, new controller managed by, and then here is the guest book. Complete R is then the reconciler. So you see this code coming back. So now that you have an idea of what code is necessary in a very small project, you can actually use something like Kubebuilder to generate the code, and you will see that it's very similar to the code that we are using here. And also, if you just go to their project controller-runtime in GitHub, you'll see that they also have some example code in their repository to help you out. So that's it. If you're using Minikube, I just always clean up after myself, so I will just do Minikube delete. If I didn't want to run it again, I just need to create the CRDs again and get it running. So if you want to run this project on your own cluster, have a look at my GitHub repository, and then you should be able to run it as well. If you run into any problems running this program on your own Kubernetes cluster, which is not unlikely because your Kubernetes cluster could have another version, you can see my version that I'm using here somewhere you can see in the Go client what version is being used. If there's too big version difference between the Go client and the Kubernetes version, you can get warnings and then it might not work. So then it's actually a matter of making sure that the client that you're using, so this controller-runtime and Go client, Kubernetes Go client, this one here, that is the same version. Otherwise, you might get errors. And if you go to the GitHub project of the client, the Kubernetes Go client, you will see that there's a matrix that shows what client version you can use with what Kubernetes version. And there's actually a lot of if you would get an error trying to run it yourself, there is a lot of explanation on the internet in the issues that it's a common issue that your client version and your server version is in a different version. It's the same if your Kubernetes kubectl version would be very different than the server version. Then you also get errors. So my client version is 1.30, which is not very far off of my Minikube version. I actually don't know what Minikube version I'm using. 132 Minikube. And what Kubernetes cluster was it actually launching? 128.3 it is launching. See, so it's not a complete match, and it actually worked with kubectl. But if you run this way later than I recorded this video, then the Kubernetes version is going to be a much higher version. And then you just have to make sure that client versions that you're using here are up to date. I'll also keep my GitHub repository up to date with what I mean is, like, I will keep my Go mod up to date to make sure that I follow with the Go versions and the Kubernetes versions so that it can actually still run on a recent Kubernetes cluster. So I hope this was useful for you. It took me quite some time to investigate this because I took quite a few different approaches that I didn't like first, but I like it now that I wrote a controller using this controller package. I like this approach very much, which is the same approach that Kubebuilder is using. So if you're building your own Kubernetes operator and your own controller, then definitely have a look at the Kubebuilder, the operator SDK, or writing it yourself using the controller-runtime. That's it. Good luck writing your own Kubernetes controller.